So I'm here with Brendan Larvor, and Brendan, you just wrote a piece called "What Thurston Says." So,
as Thurston says.
Thurston,
as
sorry,
Thurston
yeah,
says.
as Thurston
No.
says.
So this is about the paper that the American mathematician William Thurston wrote in 1994. And this is a paper that's enormously popular with philosophers of mathematics and people in maths education. It's been anthologized 2 or 3 times, many quotations. And it's a really rich and interesting paper, but it doesn't have all that much to do with maths education. And the thing you need to know is that it's not a senior mathematician just telling you how mathematics works. It's a man arguing for his life. He had been accused of publishing unrigorous mathematics, and this is his defense from the dock. So the thing you need to know is, it's not a description, it's an argument. So it has premises, it has inferences, it has a conclusion. And until you've found out what they are, you don't really know what he's saying. So, do not quote Thurston's 1994 paper unless you know what his argument is, what it applies to, and what context it serves. Thank you and good night.
So you see this, or is this kind of an example of how you should be careful when you quote or take mathematicians to say what mathematics is?
Oh sure, absolutely. Look, when mathematicians publish theorems, you can quote the theorem because it's been proved. The fact that it's in the math journal is a pretty good grounds for thinking that it's true. But the thing about philosophy is that the fact that something has been printed just means that it's minimally coherent. The level of coherence you need is quite low, and you don't need to be saying anything true. Lots of philosophy papers are published every year. Many of them say nothing that's true. So the mere fact that somebody has published something, you need some further reason to take it seriously. And this applies to what mathematicians have to say. So whenever you find a senior mathematician saying, oh, mathematics is like this, it's a moral certainty that you can find another senior mathematician saying, mathematics is like that, right? Because the first guy is only saying it because he heard the second guy and thinks he's wrong.
So, but we're doing philosophy of mathematical practice.
We are.
So we can't trust the mathematicians when they're saying stuff. How shall we go about our business then?
Sorry, I am curious.
You should take them seriously because their understanding of what they're doing is part of the picture. But in social sciences, you don't just believe what people tell you about what they're doing. You compare what they say with what they actually do. And if those two things match up, then fine. But if they don't, then you've got something really interesting, right? If you have a situation where a really smart person like a mathematician is saying one thing, but doing something slightly different, now you have some philosophy to do. Those are the really interesting cases.
So you say that we should actually learn from social science?
Yes. Because mathematicians are human beings, so everything that's true of human beings, everything that psychology and social science have to tell you about human beings is true of mathematicians as well. So for example, they're more likely to believe things that they think everybody else believes. Mathematicians follow a crowd of mathematicians, just like any human being will follow a crowd of other humans. And you need to know this before you interview them or you read what they have to say, so that you can be critical.
Do you have examples?
Well, yeah. So let's see. So MacLean talks about the nature of proof. On one hand, he says mathematical proof has to happen in first order predicate calculus. That's the standard. At the same time, he says that proof ideas are really important. Well, there's a kind of contradiction here, because by the time you've expressed the proof in first order predicate calculus, you will have lost the proof idea, right? So you can't have both. So there's a tension in his remarks about proof that I don't think he was aware of, because, you know, why should he worry? He's a famous mathematician. He can just talk, but we can be interested, right? So right there, you've got maybe a contradiction, or if not a contradiction, then certainly a tension in his remarks. That gives us a philosophical problem to play with.
So the things we find out as philosophers of mathematics, does any of that have any value for the mathematicians, or is it just something we do for fun?
Well, the mathematicians are mostly doing okay on their own, but they do have some new challenges. So they have to think about what they're going to do with computers, right? Computers are invading mathematics as they are in all parts of life. Well, there are philosophers who think about this and who think about the way in which computers are making a difference in other parts of science, in other parts of professional practice. So maybe those philosophers have some useful things that mathematicians can learn from. I don't think philosophers can help mathematicians doing old-fashioned mathematics. They've already figured that out. But really, right? But really new things. Oh, and ethics as well. That's another thing, right? So there are ethical questions arising from mathematics. There are the technologies that mathematics can be used for. So there's a guy in Cambridge who's really keen on this. So he goes around Cambridge asking mathematicians questions like, if you figured out rapid factorization, would you publish it? And this is an interesting question, because rapid factorization would mean the end of internet security, right? And they all say yes, right? Because it would be a great mathematical achievement. And you say, yeah, it would also mean, the end of the internet economy, which would be, the end of half of the developed world's economy. And it's amazing how many mathematicians say, yeah, but it would be my discovery. Of course I would publish it, right? So mathematicians maybe need some help on the ethics front.
On the ethics front, yeah. But what about epistemology and things like that, and other things that we...
Epistemology.
So you basically, you were saying just now that in order for philosophy of mathematical practice to be relevant, it has to be ethics. So are there other areas?
No, there's ethics. There's there is the ways in which computers are changing life. Philosophy of information. There's also the philosophy of social action, right? So mathematicians have collective decisions to make, and they're not necessarily particularly good at it, right? So there's nothing much in their training that makes them better than anybody. I mean, they're intelligent individuals, but thinking about what responsibilities you have. I mean, it's kind of like ethics again, but how you can make effective decisions. So collective deliberation, right? That's something that mathematicians have to do, that maybe philosophers know something about. Some philosophers may know something about.
Perfect. So thank you very much for this.
Okay, you're welcome.